Hi guys, we are going to work some problems on solving linear equations. And first of all, we need to take care of some vocab. So a linear equation means we will have variables with exponents of just 1. So we won't see anything like x squared yet. We won't see x, well, maybe we will see some writing here. There we go. We won't see x squared. We won't see 1 over x. We won't see things like that. What we will see are things like 5 over 6x minus 2x plus 4 thirds equals 5 thirds. Okay, so you solved linear equations in Algebra 1 and Algebra 2. In Algebra 1, we started with things like 2x plus 5 equals -1 times x plus 7, right? And we had to get all of our variables on one side and all of our numbers on the other, and we solved. In Algebra 2, we still solved equations like that, but we bumped it up a little bit with fractions, just like the one I gave you. There are different methods to solve these. I like to clear the fractions out. So I look for the common denominator. I look at the bottom of the fractions and I find the number that will get rid of every denominator. So that's called the least common multiple. Or, and when we're dealing with fractions, the least common denominator. And the least common denominator between 6 and 3 is 6, right? Because 3 is, so if I skip count by 3, I get 3, 6, 9, 12, and so on. And I skip count by 6, I get 6, 12. So I have other numbers that are in common, but I want the smallest one that's common to both. That way I can get rid of everything. So I take that number and I multiply the entire equation. So every single term in the equation gets multiplied by 6. So I'm going to multiply this fraction by 6. So 5 over 6 times 6 over 1 is 5, and I keep the x with it. All right, so the 6's are going to cancel out. I take the 6 and I multiply it by the next term. 6 times 2 is 12, so minus 12x. I take the 6 and I multiply it by the next term, so 6 over 1 times 4 over 3. That's 24 over 3. 24 over 3 reduces to 8. And then I take 6 and I multiply it by the last term. So 6 over 1 times 5 over 3 is 30 over 3, or 10. Now, another way to do this is, I'm going to move it over just a little bit. When you're thinking about this work on the side, 6 over 1 times 4 over 3 and 6 over 1 times 5 over 3, I can multiply straight across and then reduce, right? Which is what I was doing. Or I can cancel. So 6 over 1 times 4 over 3, I can reduce diagonally or top to bottom, but diagonally in this case. So 3 will go into 3 one time, 3 goes into 6 twice, and then I can multiply straight across and I get 8. It's the same thing. Now I can solve my equation, right? Negative 7x plus 8 equals 10. Negative 7x equals 2, or x is negative 2 over 7. All right, so that's how we can solve those types of equations. Another type of equation that we can look at is when we have decimals. So I have decimals to work with, and maybe I don't want to work with the decimals. I count the highest number of decimal places that I have, and then I multiply by that power of 10. So multiplying by 10 moves my decimal place one time. So I see 2 decimal places here, 1 here, 2 here, 2 here. So I want to multiply by 100 to get rid of all of them. That means my decimal place moves twice for each term, though. So when I multiply this by 100 and move the decimal twice, I end up with 1x. Multiply 3.1 by 100, I end up with 310. Multiply 2.03 by 100, I end up with 203. Multiply 2.96 by 100, I end up with 296. Now I can get my numbers on one side and variables on the other, subtract 203x from both sides, and subtract 310 from both sides, and I can finish that equation. All right, so I'll leave that one for you to finish. All right, some terms that maybe you didn't talk about in Algebra 2, which is fine. Identities, conditional equations, and contradictions. This is just identifying the different types of equations that we're going to see. So the first type of equation, an identity equation, what happens is the left side and the right side are exactly the same. And when I try to solve it, I end up with 0 equals 0. So if I try to solve this equation, notice that when I distribute the 3 through, I end up with 3x plus 3 equals 3x plus 3. If I don't notice that those are exactly the same and I try to solve, subtract 3x from both sides, subtract 3 from both sides, I get 0 equals 0. This is called the identity or an identity. Same on both sides, all right? A conditional statement means there are some numbers that work. So these two examples that I worked up here, they are conditional equations or conditional statements. So a conditional equation has one or more answers, but not every number works. In this type of equation, this identity equation, it doesn't matter what number you plug in for x, they're all going to work, right? Then the third type is a contradiction. And a contradiction means I end up with no variables and an equation that's not true. So this equation's true. When I try to solve this contradiction equation and I subtract x from both sides, I get 0 equals 1. That's never true. No number is ever going to work. So that's a no solution. All right. Another thing that we did in Algebra 2 was solve literal equations. So when I solve a literal equation, it's all variables. Usually, sometimes there'll be numbers in them, but they'll tell me a letter to solve for. So in this case, I'm going to solve for L. So step back from the equation and decide what's going on in the equation. So if I look at this, volume equals length times width times height. It's all multiplication. And to undo multiplication, we divide. So I'm going to isolate the L, so I'm going to box it and then divide. So I'm going to divide both sides by WH, and that allows me to isolate L, and that's my equation. All right, last one. Area equals 1/2 base, or sorry, 1/2 height. Let's get that off of there. And then base and another base. So this is area of a trapezoid, base 1 and base 2. And we want to solve this for the height. So again, we see multiplication through this whole thing. So I'm going to get rid of the 1/2 by multiplying by 2 on both sides. So multiply by 2 here and 2 over 1 here, and that gets rid of that. All right, so now I have 2a equals h times b plus h. I do b plus b. So I don't have to distribute the h. I want to solve for this, and I have multiplication. So I'm going to divide both sides. So 2a over b plus b equals h. So now I've isolated the h, and we're finished. All right, last question. I'm going to leave this one to you, and we'll talk about it when I see you again. So application problem at the bottom. So Elmer borrowed $3,150 from his brother to pay for books and tuition. He agreed to repay him in 6 months with simple interest at 4%. So my equation is interest equals principal times rate times time. I stands for interest, P is principal, the amount that you start with, R is the rate, and we want to change that to a decimal. So if it's 4%, we want to change that rate to 0.04 instead of a percentage, and T is time in year. So if we're talking about 6 months, that's half a year. You can use 0.5 or you can use 1/2 where T is, right? So plug all that in. They want the interest first, and then they want the total amount he paid back. All right, see you guys soon.